very productive. Cool. But now you can kind of see my heating pipes and things like that. I'm kind of in my kitchen, the edge of my kitchen. But anyway, hey, what's up? How you doing? I'm going to steal Twitch and Twitter today for the Lift and Shift Foundation. Right there, you can see it. I've got a project that will be helpful for my business, my LLC, my company, Project Biotech, but also it'll be something that I will let the Lift and Shift Foundation use as a makerspace type deal. And you're gonna have to hold on 1 minute where I'm trying out a bunch of new things today. So watch this video. I have peanut butter banana bars in the microwave, actually in the oven. That's the kitchen timer on the microwave. I'm gonna pull those out of the oven. I'm gonna start my testing today, my new features for our streams by sharing a video. And this is from our sponsor, so check it out for a minute while I get stuff out of the oven. How about that? Yes, back. Cool. All right. So I'm going to share a ton of stuff. This is more than just a circuit building thing for me. I'm going to share some of the things I'm trying out as far as building on the stream, working with a stream. It's been a challenge for me to learn how to stream to people, how to show you cool stuff and make it entertaining. So I'm trying out a bunch of new things today. One of them is that video to kind of help with people who might need help with insurance or don't realize they might need they could save money with a prescription benefit plan. I can't say that very fast today. There's a whole bunch of stuff going on here today. So stick with me. I'm gonna take breaks in and around. First, I'm gonna share these cool little snacks that I've been working on. They're actually super healthy and only 3 ingredients, but they're still super hot. They just came out of the oven, so I'm gonna wait before I do that. But what I am gonna share today is let's check it out. Up here on the upper screen up here is DroidCam. It's my second phone is right here. It's actually right here. It's a backup phone that I use for a nonprofit. To do some streaming and things, and right now it's running an app called DroidCam, so it's connected to my computer through a Wi-Fi cam server, and I use it to run 3D print servers, Octoprint for the phone and things. It's kind of multi-purpose today, but it's showing you my desktop right here on the screen, and we're going to switch back and forth between that view right there. Check it out. Check it out. Oh, check it out. There we are. So we're gonna be changing views. Usually I use my keyboard, and I struggle with running back here, back and forth to the keyboard. And what I realized today is, check it out. Streamlabs. We use the Streamlabs app to stream everywhere. Streamlabs actually has a like app for their phone to change the scene. So check it out. Ready? There. I just changed the scene. You can see the scene I have set up here. Changing the scene back. I'm going to be using that today to try to change scenes and get my desktop cleared off here. So hopefully my keyboard can go away in a little bit, and we can only use this part. And I'm going to sit it right here just so we can see it, so you'll be aware of it. I think it's super cool. I was talking to our design team about possibly building a keyboard, something USB that plugs in, or Wi-Fi that lets me do this, and I just figured out that Streamlabs has this app, and it connects right to the browser and everything else. It's super cool. So check it out. In fact, I'm going to take some screenshots through the day, and I'm going to be tweeting it. So we have this window open so that I can tweet stuff. I'm going to live tweet stuff as we do this. And the first thing I'm going to do is go to our nonprofit page, where we actually tweet a lot about veteran benefits, science, technology, that kind of stuff. You can see a lot of veteran type stuff about our programs, but there's a lot of benefit there, and I'm going to be tweeting a thread here about my stream today. So that's just one other way we're gonna work on making this cool and explanatory. So I'm gonna grab screenshots out of Streamlabs. You're gonna see. Oh, wow! We're using both keyboard and the phone, but you're gonna see the screens back and forth. So I'm gonna tweet, grab screenshots of the actual stream and throw them in Twitter, and you're gonna be able to see it right here. So let's do that right now. Actually, let's grab a full screen right there. I'm gonna use my keyboard. I'm gonna use the grab function. I'm just gonna grab Streamlabs, and I have no idea what this looks like on your end. For me, it pauses all the windows. Oh, I want to grab a better view of that. So let's wait for the logo to show up so we can do something cool. So we can make it look like it's us. Dump. It's gonna rotate, right? Meow. Oh, we got it. Just in time. I was mashing the wrong buttons, because that's what I do. I'm a big dumb animal, folks. So there we go. So you can't see it right now, but I'm actually looking at the screenshot. So we're gonna grab that screenshot, and we're gonna do this number. We're gonna copy it, and we're gonna paste it in. Oh, I kind of wanted a different view. I didn't want my big fat fingers in there. So let's close that. Let's try it again. Let's check out this. And I will do that number. And we will share our view here. Ready? Cool, now we got it. And I'm going to do the Control or Windows Shift S button in Windows to grab a screenshot. We're going to copy, paste right into Twitter. This is something you can do to promote your own streams and things. I'm just going to copy, paste right in. First sample is today we're trying out Streamlabs. Today I'm trying out Streamlabs. and I'm going to tag Streamlabs deck app, which is working great. Cool. First break. For a teardown. Those snacks just came out of the oven. Dun dun dun. Cool. So that's what I'm doing right now. Oh, you can't see that, can you? I wasn't even sharing that. There. I went back to the big screen. Cool. So that's what I'm typing in right there. That's what's happening, real live. And I'm gonna slide my screens over a little bit so I can see some things happening. I'm digging this though. I'm digging this app. Very cool. And dun dun dun. Now I'm gonna tweet on that tweet for the rest of the day. I'll start the thread there, and we'll go through everything else. Cool. I'm getting the hang of this, going to my phone instead of the keyboard. I had hotkeys set up on my keyboard, so yeah. So now I can probably go back and show you my fancy bars here. I've been working on a healthy recipe. These are peanut butter banana bars. There's only 3 ingredients in them. It is bananas, oats, like oatmeal, like whole oatmeal type thing, and peanut butter powder. So that they're pretty good for you. A good source of protein, not a lot of fat, and the carbs are not sugar carbs. They're starchy carbs from the oats. There's a little bit of sugar from the bananas. I'm gonna eat one now because it just came out of the oven. Not bad. Like I said, I've been working on the recipe. Something I'm trying to perfect as a health treat after exercise, working out, run, whatever. Not bad. Probably not why anybody came to the stream, but still cool. By the way, since this is a founder takeover type thing, I'm just gonna say it. I'm a big health fan. I'm starting a new company to get into health technology, and food science is a big part of health in general. So this is cool, and I dig this. I'm a big marathon runner, if you can't tell. So this is a great recovery food. A lot of times after a long marathon, you'll finish the race and you'll get there and you'll say, "Oh, here's your medal," and then there'll be people that are handing you Gatorade, bananas, bagels, that kind of stuff. So this is pretty much everything they would hand you, in a nice, neat little package, and it's still warm. It's so good. I'm gonna say, I'll eat this one. I got a dozen of them over there. So I'm gonna eat this one real quick. We won't take a break for it. I'm not going to play the video again. I'll just sit here and chat a little bit about it. These are actually really good. The way I sliced these bars today, they're probably 60 calories each bar. And if you're curious, it was 2 bananas, mash them up super good. Pour in about a cup of oatmeal, like whole oatmeal, I wasn't using the steel cut, just the regular oatmeal. And 3 heaping tablespoons of peanut butter powder. Mix it all up, flatten it on a pan, slice it up into bars about 1 inch by 2 inches. Works well. I dig it. It's not bad so far. I was thinking about some cinnamon. Cinnamon is supposed to be good for you. There's some research out there that says that the actual chemical that gives cinnamon its flavor also promotes fat traveling in your bloodstream and breaking down into from the fatty storage, basically like your fat breaking down into fat like stuff that can go in your bloodstream. So let's think about adding some cinnamon to it. But yeah, we'll see how this works out. I don't want to drag it on a whole stream where I mentioned circuits and things. I'm talking about my food fetish. But I'm a fatty. I'm literally like the character out of Tommy Boy. I'm a fat guy in a little coat. I'm a big dumb animal. That's me. Okay, I got some snacks. I got some water. Just a splash of cranberry juice. Because I like that. Okay. All right. The real reason we're here today. I am an electrical engineer. I shouldn't even say that anymore. I do like no engineering anymore. I run 2 businesses and I work in a lab and help other doctors do science. So maybe I'll stop saying I have an engineering background. I have a degree in electrical engineering. How about that? I want to build some circuits. I want to start making some circuits. We have a design team on the in the Lift and Shift Foundation that built a prototype, and I don't have the prototype around right now, but they built a prototype robot, and it worked out. It was super cool. And now I want to build the motherboard, the brain for it, without like spending a lot of money having to go like ship out to a manufacturer. Just the prototypes, just like 2 boards for us to crash them around with in the Battle of the Bots. I want to do surface mount boards. I don't want to do the perf boards and all the pinholes and things. I don't want to do this because it gets very, very bulky and very, very out of the way and exposed, and it's hard to fit into a robot. I want to do this, like that. So there's a big difference here, right? Yeah, kind of. Okay. So this is very hard to do without a microscope and a bunch of, complex stuff. So a lot of people will fabricate their own production for like prototype boards, and that's what I've been working on. I have a 3D printer that's set up with a laser. I may break that out after a break and show you about it. Show it off to you. But there's a laser that I'm going to use as part of this process of cutting films and laying them on bare copper boards to kind of like erase all the copper except for the little tiny like copper wire lines that are left over, and that's how you kind of make a circuit board. Then you have to melt on all the parts, all these little. Let's use our fancy thing. So all these, if we take a peek at our Arduino here, you can see that all this stuff is kind of like melted on the board. And it's just, it's there. So what I want to do is to be able to melt all this stuff on the board. And you can't really do this with a soldering iron. A soldering iron is very, very hard to reach all this stuff. So a lot of times people will use a hot plate. It just so happens that a lot of people will use an iron. So let's take a peek. Let's go. Let's dig into this. Before I get into the project, let me give you a little background in it. So the background is that you can use a hot plate to heat up the solder, and the solder will join everything to the boards. So let's take off to Google. I'm so excited for this right here. So let's open up another tab, and let's check out solder surface mount iron. So check it out. So this is a surface mount product from DigiKey. So we can open that and take a peek at it. That is a hot plate like that, and it's meant to heat up a board so that you can add parts or take parts away from it. And that's $350. Super cool. It's kind of overpriced, overkill for the things I want to do. There are a lot of other videos about people who do this. And I'm gonna go to. I'm a big fan of Hackaday. So we're gonna use Hackaday. I'm gonna go to Hackaday. Hackaday. Surface mount. And there we go. SMD soldering right there. So you can see this is a really good project right here, where somebody has taken an iron and turned it into a hot plate so that they can heat up their stuff. Let's take a peek at this article right here, because this is very good, and this is where I was reading it and I got the idea from. This looks like it's done overseas, maybe in Europe, because because of this relay right there that I see at the top of this picture. I got peanut butter banana bar in my teeth. So this is super simple. It's a 13 amp. You can see it right here. It's a 13 amp thing with a control board. There was a lot of work into this. And yeah, so that's a thing. That's a thing that really wasn't really wasn't very well shown on here, but they're repurposing a laundry iron right there. Obviously, people use skillets, hot plates, toaster ovens, all kinds of things. There are literally all kinds of things that people use to do this with. Toaster oven? Sorry. Hard to get the word today. Toaster oven is what I'm thinking of. People sometimes stick their circuit boards in the toaster oven and let it heat up the board so that all the solder melts, all the parts to the board. And it's called reflow soldering. Sometimes you may have seen it on there. I just love tapping my phone now to do this. This is so amazing. So you can see right there in that YouTube clip the big words, reflow plate is what they're calling it. And that's probably the technical term, but I'm gonna take on this project of building one of these, and I wanted to get started today. You can see they have a carbon fiber board underneath of this, and some maybe an Arduino. That's an Arduino mounted to some relays and heaters or power supplies to heat up the iron, and I used my keyboard this time. This is wild to be able to reach either place, either or. Kind of cool, but anyway, let's see. Let me come back to a different view. What I'm gonna do today is I'm gonna look at. I'm gonna look at a little iron I have, and I really want to figure out how to do this. I've had some ideas. So let's just check it out right now. I'm gonna move my keyboard because I can, and this is amazing. So let me get rid of my snack, move my keyboard because I can, and plop down this iron. I have this iron. I've had it for a little bit. It's the only iron I own. I don't do a lot of ironing if anybody asks. I needed this actually for another project. I was working on some countertops. And countertops have glue on it that you can, like the end caps have glue, and you can use an iron to actually heat up the glue so that it sticks to the edges of the counter, blah, 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 all kinds of stuff. But this is like a $10 iron from Walmart, Target type place, and it's got the hot plate on it. It's got steam. Can you hear me on this view? Is this view have a talker? This view does not have a talker. Oh, yeah, it does. I see it. Okay, cool. All right. Just checking. Gotta keep me on my toes, head on a swivel type thing. And it's got a temperature dial that includes the off. So I don't think we would ever use the steam, so I don't think we would ever use this. I originally thought what I might do is 3D print a stand for this, and I still might 3D print a stand for this just so I can sit it like that and not have it fall over. So let's push that button in right there. So it actually stays just like that. I could use it like this, but there's a dangerous, like, it's gonna tip over type thing. And if I'm throwing on a chip like that, there's a bad chance that it's gonna roll over or do something crazy. That is not what I want. So today I want to take the housing off here on the bottom, and I want to see what is inside of this, and maybe I can move the temperature off to the side, like they've done in that reflow plate example. So let's check this out. So I'm gonna take a break here in a minute, and grab some things, refill my water and stuff, and come back and tear this down and see what the inside of this iron looks like, see what we can do with it. Before I take the break, we're going to grab another screenshot. And I'm going to get my keyboard out of the way, because I can now. This is so cool. I can put my keyboard down below. So we're almost ready. I'm going to grab some stuff here. We're going to do this number. Oh, cool. Dun dun dun. All right, all right. So you can't see this. So you can't see this right now, but I just grabbed a screenshot from the Streamlabs app, and now we're gonna go to Twitter, and I'm gonna grab my keyboard. So we're gonna go back to Twitter. I'm gonna tweet right before the break, and let's see what's up. What am I gonna say here? Me again. How about that? Me again. Just talk through the basics of this project with an example of heating up reflow soldering with this laundry iron and Arduino. Taking a break, then taking things apart. Join me. How about that? And I'm going to stick the link to our oh, I guess I should, we'll do that. How about that? That was super easy, right? Cut and paste. Dun dun dun. Join me in 5. How about that? Cool. Very cool. There we go. Check it out. Excuse me. So let's come now. I can start closing some windows. Got some things going on. There we go. Okay. So now we see it up here. I'm gonna take another break in a minute, and when we come back, we're gonna take this iron apart and see what it looks like inside and what we can move around and do things. And then maybe I'll open up Tinkercad, or even Fusion 360, and maybe we'll try to model some of this stuff. Maybe make a plate for this. You can see my hands. Look, Ma, no hands on this screen. We'll come up with a way to like print a new holder. Maybe if it's possible, we'll look at this and come up with some ideas. I'll break out my calipers and things. We got the screwdrivers already out. Everything's ready to go. So go to the bathroom, go grab a drink, go do whatever. I'm gonna be doing those same things, and when we come back, I'm gonna play my clever video, which is a little break video, and it's I want to actually take the minute to explain. Well, I don't, because I made the video and I really want people to pay attention to it, but it's an important thing that I wanted to do this partnership with CleverRx. So it's as a person, and a veteran and an American who has experienced high cost of prescriptions and medical care and all this other stuff, and PTSD and everything else. I think it's something that everybody should look into, and at least go to the website and find out if you can get medicine for cheaper, because healthcare costs are spiraling, and it's not getting any better. So watch the video, check it out. It's going to loop a couple times. I think it's 2 minutes long. Not even 2 minutes, maybe like a minute and a half, 90 seconds. So I'm going to let it loop a couple times. I'll come back. We'll do some things. We'll take some stuff apart. That's my favorite part about being having an engineering background, not being an engineer anymore. But when I was an engineer all the time, taking stuff apart is fun. And building stuff so you can break it and figure out why it broke so you can make it better. Those are my two favorite things to do as an engineer. All right, break time. Hey, what's up? I'm back. I know I'm about to choke. Hi. Perfect timing, right? Cool. I'm noticing that the good part about this is that I've set up the scenes in the Streamlabs desktop app right here, so that even when I switch scenes, the different mics are on or off. So my USB mic right here, right in my face, is turned off for the videos and things. That's cool. Even when I mash the buttons from my phone on the Streamlabs app, the deck thing. So let's get into it. Let's tear stuff apart here. I'm digging this setup. So we're gonna come back to our full screen view. I wonder if I can have my. Can I do that here? Webcam. Oh, hey, there's my there I am right there. Cool. I can add me right here. Very, very cool. All right. Let's do this. Let's do some chat about this. Normally, you would heat this up so that all the solder melts, and when it melts, you can stick all the parts and things on. So even if I order boards out, I may need this thing to work, because I may need to add the parts on it and like complete the boards myself. So regardless of where the actual boards are made, from like a board design perspective, all of these little parts don't always come on the board. Like all these parts right here don't always come on the board, just like this breadboard. So if you order a board, you might just get the bare copper board. And I don't have a good example of a bare copper board right in front of me, but I'll try to find one after this and give a better explanation for that. So I'll come back to that. We'll just dig. Let's do it. I'll put that down. We'll dig into it. So how do we take this thing apart? That's easy. We're gonna flip it over. There's a couple of these caps right here. So we're gonna try to pop the caps off. I'm gonna grab this pair of tweezers. We're gonna see. Oh yeah, they're like flexible rubber caps. So they're probably screw caps. I'm just gonna do this number and pop them out. Try to grab them. I don't want to destroy everything. So there's one. And that's just a regular Phillips screw in there. If you can see it right there. So yeah, let's take that apart. Let's take this apart. Ooh. You don't want to come out of there, do you? Why don't you want to come out? Come on, it's not that cool to stay there. You are really not helping anyone. Okay, that might be something we get angry about in a minute. Ooh, this one too. It is really in there. Wow. Are they glued? Those might be glued in, or like heated in. So let's try a different approach there. Instead of the tweezers, let's grab a flat. Let's grab. It looks like this is a flat. Yeah, this is a flat edge right here. We're gonna grab this flat tip screwdriver and try to pry it out instead of the tweezers to kind of pull it out. And yep, it definitely appears like it's glued in. And no, it is not coming apart. Very easy. We're just gonna have to wreck it, I think. There we go. So what is... Oh, it looks like they poured plastic onto... You can see the shape of the screw head. They just poured the plastic in there, it looks like. Oh, that's wild if that's true. Yeah, because there's still some plastic right there, and the edge. That looks like silicone, like a rubber type silicone is what these caps look like. And it definitely looks like they just poured it right in while it was still like wet. Kind of wild. Oh, that one almost got away from me. So yeah, you can see that one here. It's still got like all the shape of the screw head in it. Like it was buried in there. So let's see if we can those look like Phillips screws. Let's grab a screwdriver. In fact, I think we're going to go with our robot screwdriver. We'll try this number 1 here. Phillips screws are labeled with like number 1, number 2, number 3, number 0, number 00. Whereas the flat screwdrivers have like a size on the edge of the blade, since it's just one flat line. And these are really in there. Wow. Okay. And this is kind of like awkward because it's stubby. So this part here is kind of in the way. Like I can't get my hand on the stubby end of the screwdriver here. So we're gonna grab a longer screwdriver. I'm gonna put this back because I need to go back in the case the way it came out, because it's part of like being obsessive about that kind of stuff. So we're going to use this longer screwdriver. It's actually from our robot kits. I'm going to flip this around. One end has a hex head. The other end has a Phillips head, a number 1 on it. So let's try this out. There we go. Now I can get some torque on it, turn it. Easy, much easier. It's probably easier, a better view for me to turn this up and do this vertically instead of sitting it down flat on the table. Cool. Screw number 3 right here. Look, almost out. Screw number 4 right here. Almost out. Let's see, how do we do? Oh, so close. That's loose. That's loose. It looks like everything's loose here. There's something holding us back. It might, it looks like the wire. The wire is holding us back. Okay, so let me drop screws. Let me turn this upside down so I can drop some screws. There we go. Dropping screws. All the screws look the same size, so putting them back won't be a challenge. If I want to put it back. And these are heavy wires because this thing uses a lot of power, and it needs big wires to make sure that it doesn't melt stuff. So that's a bit awkward right there, but it's okay. And you can see here that the temperature setting is actually just a dial right here, so we might be able to do something with that. We might be able to move this somewhere. I see it's basically a big potentiometer, a big dial that turns. This part turns right here, and we could like grab it and turn it. But it also means that we can move the switch. And I'm curious to see how that would work. It's possible we could just take all this stuff off of this plate and put it on a plate next to it and just run with it. So maybe that like this thing works just like, well, if this cooperates with me here. Doesn't want to come out. Why not? Well, we can leave it like that. But maybe it's possible we do something like this, where this switch here turns, or we just grab those pieces from this switch right here. This part, oh, because this part comes out right there. Check it out. So we can, it's no good for you to see, so let me do it this way. We can plug this in right here like that, and actually turn. See it? You can hear, if I'm really quiet, you can hear it click. Right there to turn on the power, turn on, and the thermostat switch. So this is a potentiometer, but it's based on temperature. It's basically like a thermostat type switch. So the thermostat, when the temperature gets above or below that click, it lets the power go through it so that it keeps things on. And yeah, that's the basics. But this part works right here. So really all we need is this fancy dial. This fancy dial right here to tell us like what the temperature is. And I think we could probably pop that thing right out of here. Can we? Let's take a shot at popping that right out of here. Dun dun dun. Super cool. So that was really the only part we needed out of this, right? The rest of this is kind of useless. Awesome. And this just slips. This part, let's check it out. So this part slips right in here, so you can turn it like that, and it actually, oh, look at that! It clips right on, right there, and now we can see the whole thing turn. You can probably hear it. That's like room temperature right there. That click. So this would turn on at room temperature. That is super cool. Yeah. I dig it. I dig it. Maybe we make a box. Maybe we make a box with a gear so that we can flip this upside down. Maybe instead we 3D print a gear that goes on here. That clips on there and it goes to the side. This is where I'm gonna switch. We're gonna switch it up and do something different. And I may make a gear that goes on here that and something that holds all this stuff down, right? Like that. So that way it's not in the way. And then this gear that clips on here, and it's maybe it's a very wide gear. Maybe it's very big like that, so that we can sit this knob on the side right here and turn it, and it turns the gear. So it would have to be 2 gears, and if we want to keep the ratio for this, we need the gears to have the same same number of teeth, so that we keep the same ratio for turning. And then this dial would work the same as this right here, and we would know off, and max are right there. So we could still use this same dial and even maybe part of this same thing here and 3D print a new knob for this. So I think I'm gonna ditch all of this. There's an LED here in the front that says that it's on. That could probably go. It's like a little lamp right there. We could probably cut that out. I don't see where that's necessary. So that's one wire that comes off of here. And these are 2 wire nuts right here. You can see the wire nuts right here that are holding the power, actually connecting the power to all of this. So this is a very, very, very simple device, the iron. It's basically this heating element here, getting all this power on these 2 blocks, and in the middle of it is this switch, turning things on and off. Very, very easy to work with. And the LED, the light here, maybe we move that somewhere else, so that we have a warning light, so that we have a warning to say, hey, our thing is on now. And I dig that. I dig the idea of moving that off to the side. Maybe we turn it this way so that it's off to the side, and we have a panel on this side that works with this and holds all this together. So we've got these screw holes here. Yep. So maybe we focus on these 2 screw holes and come up with something just like these screw holes right here, to hold this thing down. And then to the side we have another platform where we build something. I'm digging this. I'm starting to like this. I'm thinking maybe we hop in. Let's try Tinkercad. I like to use Tinkercad, mostly because. And I'm also realizing we're gonna have to snip this to get the wire out because it's got the plug on the end. So I'm not gonna disconnect everything from here. We're just gonna snip right here. In fact, I'm gonna do that right now. We're gonna use these. We'll use these snips right here. Check it out. Just a pair of regular like wire cutters. I'm just gonna snip right there. And right there. Maybe not. Okay. And let's grab these needle nose, these little needle nose pliers. And we're gonna pop this right off. Dun 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 dun. Dun 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 dun. Almost. Mr. Non-cooperative here. Why won't you just go? Oh, it's because there's a tab underneath. I didn't realize there's a tab underneath that I did not snip. Okay. So let's try snipping this tab right there. Ready? Ready? Oh, snap. Gone. Done. Out. Now we can slide that out. There we go. So now we can work with this separately. And we might want to use this as a model for a plate, a bottom plate to flip this over. Check it out. And there's our buttons. Button for the steam. Doesn't seem to want to work anymore. I don't know what was holding it up. But I think we're done with the steam anyway. So, oh, there it goes. Might be cool to play with later, but I don't really. That's not something I generically have a lot of time for. Let's unscrew this and see what happens when we unscrew it. Like that. Cool. Oh, it's just a circuit board type washer. It's that plastic circuit board material made into a washer. So this could absolutely move to the side here. We could do something like that and sit that to the side and have it on a plate so that it sits up like that. You see I'm getting phone calls, right? This is the fun part. Telemarketers. I recognize the telemarketer number because of the area code. But so here's our power light. We can definitely move it to the side. We can screw it down to something else just like that. So we can definitely make a panel that this sits on, and move our light to the side, and move our temperature knob to the side with a gear. So our new plate will probably look something like this. Yeah, I'm digging it. I'm so digging it. Yeah. This is exciting. So our hot plate will be moved. Let's set this aside. Let's what? Oh, yes. Let's come back. Okay. So I want to change gears. I want to do something. Excuse me, a little different from taking this apart now. I want to start modeling apart. I want to start modeling this this new base, this new handle. I want to recreate something that matches this bolt pattern here, that this hot plate part will sit on. So that's the new plan for for another, I don't know, hour or so. I can do this for. I'm not gonna finish it today. We might get a rough plate done, something that I can print and I can come back and I can show and we can put this together. So that would be cool. And I think the plate is something that is gonna print. It's gonna take hours to print, to 3D print. So that's probably where I'll end the stream later. Well, and I'll go print it. Maybe I'll come back next week or something like that. I'll be stealing more of the stream time to work on projects, and this will be something I can come back and we can work out like a gearing, and print the gears, because they'll probably print very fast, and that'll be fun. That'll be a fun project to wrap this up and move the thermometer, the temperature dial off to the side. So that's my plan for the rest of this stream and the rest of this topic. So bear with me here. What I want to do is grab another screenshot. We're going to go back to the full screen view. I'm going to grab my keyboard and we're going to check it out. So we got this iron apart, this hot plate apart, and I'm going to grab a snapshot right there. Except I look like a weirdo. How about that? Let's skip that. Let's wait for it to rotate again. Oh, I guess we didn't have to wait for it to rotate. I'm picky about getting our logo, and it's coming up again right now. So no, did I mash the right buttons? No. Oh, it's my keyboard not cooperating. Ah, wrong logo, but that's okay. So I use the keyboard, the snip and the Windows snip thing, and I just grab the keyboard, the view of the Streamlabs, and I'll copy it and paste it right into to Twitter. So here we go. Ready? Don't. Let me type some things up. Let me lean back so I can get a good shot here. What do we do here? What do tear down? My iron teardown is done. And I talked through a plan to 3D print a new housing that moves the power switch, the power dial, and indicators taking a break, then we're digging into Tinkercad. Join us. Can I add the same? Oh, nope. Don't want to add the same picture. But I want to grab that that thing right there. So I'm gonna copy the letters just like that. Dun, 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 dun. Cool. Let's do this. I'm psyched. Tweet. We'll view it so we can come back to it and finish this thread later. So here's our thread, and this is the cool part where I'm helping you with some marketing. Hopefully people are catching this and maybe some people will show up in the stream and realize that I'm giving you like the behind the scenes. Here's how it's working right now. Here's how you can help yourself if you have a good Twitter following. We don't, because nobody's coming to talk to me. But we'll work on that. We'll fix that. Anyway, yeah, nobody's coming to talk to me. Nobody's coming to check us out on Twitch or anything else right now. It does. So it says. But I'm gonna take another break. Then we're gonna wander into Tinkercad, and I'm gonna design some things in Tinkercad. When I come back, here we go. So when I dig this whole new phone thing. When I come back, I'll or in the break here, I'm gonna dig around and see if I can't find a blank copper board, and liquid solder, my laser, and all the other parts of this project, so I can finish up today with leaving like this like summary of what's up. I don't know if anybody watches a whole Twitch thing just to see like a summary, or maybe I should have done the summary first to keep people interested. I don't know, but I wanted to take stuff apart. Really, that's what I do. That's what we're here for, right? Okay, so I'm gonna take another break. I'm gonna let our little clever vid cycle a couple times while I figure out who this telemarketer was and work on some other handful of stuff. Watch the video. Dun dun dun. Hi, back. I don't see my little sound meter thing. It always freaks me out. Okay, I see it. I see it now. I see the sound meter. I see the sound meter. Okay, cool. Back. And it's probably the last break I'm going to take. We've been at this well over an hour. Probably get into hour and a half, 2 hours, which is kind of long for me. I usually do this for like 40, 45 minutes, less than an hour on Thursday nights, and I do something technical. So when I steal the stream on Saturdays, the goal is always to stream for a couple hours if I can. I'm a little overwhelmed with time and have another project I need to work on this evening to get into a 3D print production. So I'll probably get this started on my 3D printers here and then close things up and go work on some other stuff that I can't stream, sadly. But anyway, so let's do this now. This is gonna be a bit awkward for me because I need this stuff out. I need to be able to measure these parts, but I also need to be able to look at my web browser and share my web browser. So I'm gonna open up some browsers and things, close some other windows, make my desktop here a little more manageable while we do this. Cool. So I need to open, excuse me, Tinkercad. And I need that shared with you. So I gotta break my keyboard out. Let's get into Tinkercad. You can see like on the screen, like my screen over there shining on me. I see that now, and I'm like, oh wow, look at that. I don't have the overhead light on. I just have the mood lighting on. So there we go. Now I need to change my view. I need to change this view here so that you are looking at, what is that? So that we are looking at no, that's not the options I want right there. There we go, my browser. No, why do I not have... Boo! How do I not... I can't share Tinkercad with you? That is terrible. I guess I'll have to open it on this browser. I don't know if I have my login, though. Let's see if I can find my login very quickly. How about nope. I don't know what my password is. Let's go find out. But I'm very sad that I can't share my browser with you. Oh, there it is. There we go. Dun dun dun. Got my browser back. super cool, so I don't have to monkey with finding my password. There we go. Okay, so let's do this. I'm gonna lean my keyboard right on the edge there. I don't think I need my keyboard. Like the cool part about Tinkercad is I don't really use my keyboard too much. So let's get into this. Let's get into a little bit of this. We're gonna create a new design, and we're gonna do some quick measuring. I'm gonna get tools out of the way. I don't need these snips or this needle nose pliers. Parts. We will swap for a digital caliper. So let me get things out here. I'm showing you the tools of the trade here when I work in Tinkercad is basically a digital caliper. So we're going to be measuring a lot of the pieces right here, and I'm just going to slide my keyboard on here just in case I need to mash some numbers in on Tinkercad. And let me get a good view of both the browser and the stream. I think we're set up. I think we're good. Yeah, we're good there. Cool. And oh, I really want to be able to share DroidCam right here. Right there. Okay, awesome. Excellent. Yes. Oh, I think I can turn DroidCam on. Shut up. From the button menu. Snap. I'm digging this Streamlabs thing. Okay. All right. So the first thing I notice is let's check out the full screen here for a second. First thing I notice is we need to recreate these mounts for this iron so that we can mount it on here on something. So we want the iron to mount onto top of this like that, right? So we want to recreate these mounts without all of this. So that's the first thing we want to do in Tinkercad. So when I look at this, let me grab my fancy screwdriver here. There are 3 parts to this each of these mounts. There's the outside cylinder. There's the hole, which is another cylinder for the screw, and then there's this inside cylinder here that carves out kind of like a hole for the screws. So we need to know that like the height of the cylinder here, because it needs to cover all of this stuff. All of this stuff like is higher than this screw hole right here. So we need a it's called a post. And so we need to recreate this post right here. You can see that. Let's see if I can get it right in there. Yeah. So we need to recreate this post right here. And to recreate this post right here, we need to know the height and the radius, basically, or diameter of this cylinder, but also this cylinder here to make a hole for the screw, and this cylinder here. It's another cylinder, but it's a void. It's a hole. So we're going to create all 3 of those separately. We're going to create this part out of 3 cylinders in Tinkercad, and then we're going to duplicate it and bring it over here and space the distance out the same. So let's focus. That's my plan right now, is to focus on one post at a time, recreate this one post right here, and then we'll make a second post, and that'll be the beginning of our mount. So let's take it back to Tinkercad, and I just want to stop and say I use Tinkercad. I can use Fusion 360. We have Fusion 360 license for the nonprofit, and I'm getting better at switching back and forth between them. But I like to use Tinkercad on streaming videos for one reason, because it's free, and we are a nonprofit. We want to bring as many people with us into the world of science and technology, and eliminate all those barriers, and that includes access to technology, access to apps, access to education, access to, mentors, role models, that kind of thing. So I use Tinkercad, and all the modeling nerds, you can bash me all you want, but Tinkercad is free. All you need is an email to sign up for it, or a social media account, or like whatever, to log in, and and anybody can use it. It's a great tool for that. So I'm gonna go there, and this might be harder to make in Tinkercad. I get that. But I'm going to do it, and in worst case, I'll just export it or send it over to Fusion 360 from Tinkercad, and then I'll deal with that. But I want to get it started and get the idea and talk through the whole thing, because I'm big on like sharing like the ideas and the process, because it might not be clear to people how you recreate something like a mount. This thing looks confusing and complex, but it's not really. So hopefully pointing out how I'm going to tackle the very start of this project will be super helpful for somebody. And yeah, I think that's it. Okay, cool. All right. So let's start with, we want a plate. Let's go back to our design here. I'm going to just drop down a plate. Let's make it a plate. How big is this? How big is this thing right here? So let's check it out. It is, my battery's dying here, so you can't see. That's 77 millimeters. So we need this thing to be at least 80 millimeters. That way, and to cover the whole thing, it's got to be at least 130 millimeters that way. So 130 by probably 130 or 100. We'll do 100 by 130. Actually 110. We'll do 110 by 130. How's that sound to start with? So we'll touch that. I'll do 110 by 130. Dun dun dun. And this is 10 millimeters tall, I think, to start. 10 or 20. 20. We don't need it to be 20. So let's go with 5. So it's a plate like that. Whoop-de-doo. And I'm gonna cut up this plate. It's not gonna be the same size. In fact, because I know I'm gonna cut this plate up, let's actually make it the 80 millimeters. Let's spin it this way. Actually, let's spin it this way. Right? And we'll do 80 millimeters that way. So that's about the rough size of the iron right there. So we've got a 5 millimeter plate. We could probably shrink this down even more to like, I'll do 3.5 for we'll do 3 millimeters. I like to go whole numbers. So 3 millimeters for right now. That'll just cut down some of the print time. Excuse me. Okay, cool. All right, so the first question is, how big is this post? Oh, I was completely not showing that. So there's my plate, 80 by 130 by 3. Back to here. Let's measure this post. Let's see how big this post is. This post is almost dead on 10 millimeters. You can see that 10 millimeters right there. My battery's getting dead, but yeah, 10 millimeter post. And my favorite part of this digital caliper is the fact that it does this thing right here. So this has got to be up at least to 10 millimeters here, but it's got this round thing underneath, so it's probably even further. But I can see through here, like I can line up, there's a glare so you can't see it, but I can line up this post with this post. So if I line these up like this, you can see the depth right there, and that is 13, if I get the angle right here, about 13, 14, almost 14 millimeters. So we're going to make this 14 millimeters tall by 10 to get things started. Okay, so I'm going to drop in a cylinder, and we're going to make it, I'm going to drag it to the side a little. We're going to go with 14 tall and 10 by 10. Like that. And I like to crank the sides up all the time. There we go. Okay, so now we've got that. And now we need to know the dimensions of this other hole here. This one right there. So once again, to get our screw hole, I'm going to use the inside edges. We're just going to measure this carefully. Right there. It's almost exactly, you can see that, almost exactly 4 millimeters. If I pull this, so we could go with a 4 millimeter opening, and I'm probably not going to lose much sleep over the tolerance right there, or differences in my thing. I'm trying to get you to see my dead battery, but almost dead on 4 millimeters. Cool. So we'll do 4 millimeters for the opening of the hole. So I'm gonna grab come back to Tinkercad here. Grab the hole. We're gonna leave it at 20 millimeters tall. I'm gonna do 4 by 4 quickly. I'm gonna center it on this. Like that. Dun dun dun. Cool. Now I'm gonna move it. I'm gonna grab both shapes. I shouldn't be. I'm teaching right now. I realize I'm like in instructing mode, and really, it's kind of like a habit. But I'm gonna drag all this stuff around over here like that. So now we can actually work on our board. This was up 3 millimeters, so I'm going to raise all of this up to 3 millimeters like that, so it's part of the board. I'm going to drop this tube down though, because we want it cut all the way through. So I want this down on the bottom so you can see it sticking out, so that we can actually get our screw through. I'm going to carve out more later, but this is our first step here. So I think this is where we want it. I'm going to measure the distance now because I've got this set. I want to carve the hole in it, but I want to align these. I want to actually let's do the whole carve. So this was 10 by 10. So let's grab another one here. We'll make this. We'll make this 6 by 6, and I'm doing 6 by 6 that way. It's a 2 millimeter opening inside. I feel like that might be good. Actually, we could probably do like 1.5 millimeters. So we'll do 7 by 7. Like that, and I'm gonna take it back, and I'm gonna measure this part right here. So let's measure. Get the caliper out. Measure the inside here, and I was pretty accurate. That is a 7. So the wall, the thickness of this wall right here, is 1.5 millimeters. So we're gonna stick with their measurement of 1.5 millimeters, and that's a 7 millimeter thing. So this is 14 millimeters tall. This is 3 millimeters tall. So 14 and 3 is 17. So we need this to be smaller than 17. I'm gonna make this 15. So that'll give us a 2 millimeter bottom, like that. So undo. Cool. Now I'm going to drag it over here. So now you can see, like, it's going to cut away, but still leave a hole there. Now I'm going to I want to zoom in on these parts like this, because this is where I want to grab these and center them all. Like that. So they're all centered. You can see that right there. No, you can't, because you're not looking at my screen if there's anybody looking. Duh. I'm cool. Yeah. All right, so we've got this centered. We've got everything centered there. We've got this pin here. Now I want to, before I cut this, I want to line up this pin with another pin over there. So I want to grab all of those parts and duplicate them. Like that. So I want to copy and paste, duplicate, and move the whole set over here. Like that. Now I just need to know how far apart they went. In fact, I'm going to not move it right now. We're going to measure the distance between these two pins. So let's go back. Let's check it out. And this is basically the plate that we want. So I'm going to try to do center to center right here on these two pins. And I'm usually pretty good at eyeing this up center to center. But I did make the variance in that the screw hole being 4 millimeters by like 3.9 millimeters for a reason. That's I like the idea of being a little wider for the screw hole. So this looks to be about almost exactly 48 millimeters here. And I'm going to do something different. I'm going to, in order to, this is like 48.1 millimeters is what it's telling me. So I'm going to double check that on the iron by measuring like hole to hole right on the iron and see that it is also like 48.1. This is a little harder to see. For me at least. This is the day that I need glasses or a magnifying glass or something. But 48.08 is what that says right there. You can read all my dying battery. So we're going to go with 48 millimeters distance between these two. I'm going to close that, turn that off, and we're going to come back to Tinkercad. So I've got this duplicated, and we're going to move it 48. I'm going to type there 48 millimeters, just like that. Cool. So and it's not centered on this thing. So we're going to grab all of this and make sure we have 5 shapes or 6 shapes. There we go. 6 shapes right there. And as this, I'm going to try this. I don't know if this works not in here or not, but we're going to try to align this with that. Nope. I don't think I can undo that. So the 6 shapes. I'm going to have to do my best to try to align it on this line right there. Looks fairly aligned, right? Cool. And we're going to bring it down. How far should we come down? Let's take another peek at this. I think this is the part that really doesn't matter, but we're going to look anyway. So this plate was going to cover the whole thing, so we want these screws to be roughly 25 millimeters from the end. You can kind of see my 25 right there, so there we go. 25. In fact, we'll go 20. We'll go 25. This part doesn't really shouldn't really matter too much to us. So let's go with 25. And no. Okay, cool. So 25. So we're going to bring this all the way to the end. See that it's lined up there? Cool. Now, so we're at 12. So we're going to do negative 25 right there. Boom. So that's our mount. I'm going to grab all of this. Combine it all. There we go. Now we've got this cord out underneath where we can drop some screws in. Right there. And the screw holes should fit our should line up with our iron. So our iron now can sit flat on it. And then we just have to work out a mechanism for the excuse me, for the dial, for the power indicator thing. So the power indicator thing, let's try that. I'm going to try that. I want to just pin a hole in this thing, and that will be where I close up shop here for the night. So as we come back and we talk about this, we've got this iron here, and there are these two pinholes, these two screw holes, and then there's a mount basically for the power knob, right? So we're gonna create a gear system to move the thermostat knob to the side, and also to move the light to the side. So we're gonna add to this project. In fact, if I bring my browser, poof. So if I bring my browser back, so up there you can see that there's the two pinholes, and what I want to do is add a hole to the middle so that I can skip a step in printing more of this. I don't want to print this now and look at it and say, okay, this fits. Now let me do something else. So I'm going to do the next step on this now, which is adding a mechanism for the hole. So the first thing I want to do is make sure I have the parts lined up. If we take a peek here, I want to make sure I have this part lined up with a mark on this mount with our new plate mount. So I'm going to add this right here. A hole, just a hole, and then we'll build a gear that fits in the hole later. So my concern today is having the hole there and figuring out where that hole goes on this plate. So let's take a peek at our iron here. Let me move my keyboard down out of the way. Let's check this bad boy out. So this thing is a distance from here, and if we're looking at the screw hole, it looks like the screw hole is in line with this plastic piece here, just a little off. You can kind of see it's just there. So center to center should be pretty close to this here. I'm going to measure that distance right now. Ready? Then we're going to throw this on a printer. So I'm going to do that. And that looks like it is 31 millimeters exactly. Wow, that's creepy. Okay, so 31 millimeters to the center of that hole. And how big is this knob? Let's measure this knob here. 545 big. We could do something but we want to make sure that we can fit a sleeve over this. So let's make it bigger. Let's do we could do 10 millimeters. Is right there. That is 10. That's exactly 10 millimeters. That gives us room to play with around it. So if I make a 10 millimeter hole, 31 millimeters from the existing screw holes, I think that'll work. So let's go back to our Tinkercad. Dun, dun, dun. Oh, I dig this phone thing. This is so cool. But I'm going to grab some water. Bun, 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 dun. Okay, so back to Tinkercad. We want to put a hole. We want this hole 10 by 10. Actually, oh yeah, I'll do the keyboard thing. I put my keyboard away because I didn't need it. 10 by 10. Cool. So I need to measure, and that's one of the flaws of Tinkercad is how do you measure, right? How do you measure some things? We can measure. We can use this ruler right here to tell us. Like I can drop it down and spin it around. But it's measuring the plate. It's not really measuring anything else for us, right? So here's a trick I learned before. Oh wow! Oh, so the measuring got better in Tinkercad. That's cool. So 40 is the distance from the midpoint to there, and that is 10 millimeters wide. So we're at 30. So we need to move 1 millimeter that way on the y-axis. Okay. I'm cool with that. So let's move. I have the snap set, so we can just move 1 millimeter to the side. And then I can align this to the center. So just to double check that the thing is working. I'm gonna do this, which is the trick I was gonna show. Is let's make this box purple. Let's make this box .31 millimeters by that. And I feel like this is off some. So this is 31 millimeters. So maybe I moved that 1 millimeter to the other way. So we should probably move it like that. Right there. So you can see the center line. Got it. You can see the end line on this. Looks like it's lined up right in the middle of those. Oh, that might be center right there, but it's okay. So we've got this. We can delete this part right there. Let's add these. Cool. All right. That's pretty much it. That's pretty much it for our plate. So what I'm gonna do is I'm gonna print that. I'm gonna 3D print that. I've got an Ender in the other room. I'm gonna print it on PETG, I think, because that's what's already loaded in the printer. And I have to print a couple other things on there. So what I'm gonna do is print that plate. Excuse me. Do a dry fit on this this iron, the base of the iron, and hopefully, if it works out, the cool part is I could start using it now because I have the hole in there, so I can set my dial I can turn it on and set my dial and just flip it over, and then take the dial out, and then later on I can come back and I can build the gear. Oh, maybe I can't. So there was this part. Maybe we should measure this, and I should go back and check if this is 10 mil. Oh, this is I can do the button. So this part is, you can see it right there, 8 millimeters, almost 9 millimeters. So this should fit in that hole right there, and this means that I can turn the iron on and off. I can slip this part. I can slip this part right in the iron, in the plate, set my temperature, and start using this iron as a hot plate to start adding parts and do the soldering for me. And to do that, you're probably curious, like what do you do with that? Because you can't use regular solder wire. That's the thing. I'm going to grab solder wire here to kind of illustrate the point. So check it out. This is the solder wire. You can't just like sit this solder wire down on a board. If we come back here to here, we can't just, I mean, we can, but it's a kind of a waste of time to sit this here and do all this like that, right? That's just the same as like soldering by hand. So what I will do is we will set a plate here to get hot with all the parts on it, and we will use this liquid. This liquid, excuse me, because it's still in the bag. I haven't used it yet because I've been waiting to build this project. This is solder paste. I don't know if you can read that right there or not. Solder paste. So it's a solder paste, and we will paste up the board with solder, using a mask that I'm going to cut with a laser. And I'm trying to turn this thing off. There we go. Okay, cool. So I'm going to put some tools back here now that they're not needed. And this is the laser that goes on my 3D printer so that I can cut like a cover, basically, to go on a circuit board and put this paste on. And then we'll drop it right here on the board. And with the paste on, you can see it just like that. How awesome is that? Very, very, very cool. All right. So I'm going to grab a screenshot of this again. That's terrible me, right? Okay. Ready? My sleeve is driving me crazy. Dun dun dun. And there we go. I'm going to hide that for later. So I'm probably gonna wrap up this stream right now, and we're gonna wrap it up with some tweets. How about that? I'm gonna send some tweets. In fact, we're gonna screen grab this mount right here. And my mouse is not cooperating with me all of a sudden. Let's try it again. Ready? Cool. There we go. All right. So, join me in some tweeting. How about this? How do I share a different screen? And we'll wrap this up. There we go. Poof. We're back. Cool. And let's take it down, take it down, take it down, take it down. So I'm going to add both of those pics right from the browser, from the screen clip. Copy and paste. Copy. And paste. Actually, we'll do this. We'll do 2 quick tweets. Let's start with this one. Why is all of my devices are not working with me right now? All of a sudden. This mount reflow mount was fabbed up, modeled quickly. This mount was modeled quickly. And it'll go on a Creality 3D printer, Creality Ender, tonight. Make it real in at G. It was a quick Tinkercad thing. It was a quick thing in Tinkercad. How about that? It was a quick thing in Tinkercad. This mount is now a model, and now a 3D model. It'll get sliced up on a, it'll get sliced up for a Creality Ender 3 tonight, and we'll make it a real, and we'll make it a real PETG thing. We'll make it real. And some PETG will make it real. And some PETG will make it real. How about that? We'll make it real. It was a quick thing in Tinkercad. Very, very, very cool. All right. We're just about done with the beginning of this project. Why are none of my devices working here? Hey, okay, so I'm having some real struggle with connectivity between my devices, which is a little awkward and odd. Let's see. I wonder if it has anything to do with all of this wireless stuff going on right here. It might have something to do with it. I'm going to unplug my Bluetooth headset, which is right next to my Bluetooth mouse, making things a little awkward. Could be a reason. Could be the key. I've moved the keyboard now so that it's in line with all the Bluetooth receiver, the Bluetooth mouse, some other things. So just things I'm noticing here. But anyway, this is basically the end of my stream. I'm gonna close up with the same video I opened up with. Actually, I will not do that. In fact, I'm not going to play a video at all. I've been around for 2 hours. What I'm going to do is hop off here, tweet a finale type thing that says go back and check it out. This was everything. Let's see. I can delete that one. Do that stuff and yeah, no, I'm not going to get into the slicing and all the other stuff because it's been 2 hours, and like I said, I have other projects that I can't share right now, but I'm very, very psyched about this project, and if this mount works out, then I can actually ditch the housing for the iron and all that stuff and reuse the screws to attach it to a plate, a PETG plate, and that'll be exciting. I'll be able to use this iron as a reflow station. Excuse me. And this basically only works for surface mount stuff. I mean, you could probably get away with doing it with through hole stuff, but I'm not quite sure. The benefit of that, you would have to probably drill some holes or fabricate like some kind of heat sink to suck up heat. Not a fan. But anyway, this is cool. I'm glad I got to do this. Coming and stealing the stream actually helps me with a little bit of procrastination. Do I want to do this now? Do I not want to do this now? If I tell myself that I'm going to stream this for you, for us, for anybody, all of a sudden, then I'm kind of like, it's the good thing about social media is that when you know people are watching, you got to go through with something. You feel the pressure to not procrastinate, not to like give up. And I use social media for that purpose. So a lot of times I'll share my runs, my exercise, my the things that I procrastinate on. That way I kind of like put it out there for everybody to see and like yeah, I'm doing it. There it is. So I'm telling you I did it, so you can do it too. Cool. All right. And I just passed the 2 hour mark, which is kind of good for me, kind of big for me. And that's about it. We're gonna stream Battle of the Bots next week. So up there in the title, we're gonna stream Battle of the Bots next week, and it will be it'll be fun. We have some new plans. So I will actually stream the thank you video, and that's where I'm gonna be done. I appreciate it. It's the highlight video. It's more than a thank you video. Ready?
smoke in your house, don't smoke in the hall. You know what I mean? Like, walk around.
For this side. On your mark, get set, go! Point for the side. These guys.
Let's go. Have at it. Oh. Oh, and they're struggling. But they're not giving up. It's still a fight. It's still a fight. It's still a fight. What are they? There he is.
No, yeah. Oh,
He's-
who got it? Who got it?
Best 2 out of 3.
3, 2, 1.
Go. Go. Have at it. Oh! 2 batteries down. I think that might be a draw.
Yeah, I'm gonna draw.
That was hysterical.